Hello everyone, welcome to this video. In this video, we are going to cover the chapter triangle, and it's the very basic requirement for our next chapters, which are quadrilaterals and circles also. Okay, if we are familiar with this chapter properly, then we know about like 80 to 70% about these topics. Okay, so we can say this is our basic building for the next chapters, and if we do them correctly, then it will be very easy for us to cover the next chapters. So in this chapter triangle, there are the topics listed which we have to cover. First of all, it's congruence of triangle. Okay, but before that, we will do some basic definitions which you already know. We will revise them so that the concept will be more clear. After that, we can ready to cover congruence of triangle. After that, we will do criteria for congruence. Okay, this word seems totally new for you, but it's not that much difficult. You can relate congruence means just equality. Okay, in the case of geometry, we will do this properly. Now, when these two are completed, then we are able to do some properties of triangle. Okay, and we will do some proof also. Now, the last part of this video, in which we have to do the inequalities in the triangle. Okay, this is also like property based, but little bit different from the third part. Now, coming to the main part of the video, first of all, we will define actually what the triangles are. So in this topic, congruence of triangle, I am starting with the triangle, actually what it is. So it's written there, a triangle is a closed figure formed by three line segments. Okay, it's closed, so we can draw like that. This is the triangle. Okay, these are line segments, this one and this one and this. So it's the closed figure which is formed by three line segments which are joined end to end. Okay, this is the criteria. So we can say yes, it's the triangle. But here it is written end to end. So if I make like that, but for the third side, suppose I make this. So there is the gap. Okay, it's not closed. So we can say it's not a triangle. Okay, it's not a triangle. So very basic conditions for triangle is that they should be closed and it consists of three lines. Okay, so that's it for the basic definition. Now in the triangle itself, we have some words like it has three sides, three vertices and three angles. So if we name this triangle, then it may be like this A, B and C. Okay, like sides, we all know this is the side like AB. Okay, and BC, AC, this whole thing. Okay, this one is one side, this is another side, this is another. But these vertices, we have heard this like maybe it's new for you, so I will explain it like more clearly. Now third one is angles. We have also done in the previous chapter lines and angles, so we can directly say this one is angle and we can denote it as angle B. This one is also angle and we can write it as angle C. This one is also angle and we can say it's angle A. Now the vertices. So it's written there corners in the bracket. Yes, so we can directly say these corners are our vertices. And it's written there the 3 points where the sides of triangle meet, which means this is side AB and this side is AC. So they meet at a point A, so we can say A. Similar thing for C. Here these two sides are meet, AC and BC. So we can say A, C and B are three vertices. of the given triangle. Okay. Now the same thing is written there, which I have already explained. Vertices, they are the corners, okay, and the sides, they are the line segment that form the triangle. Angles we have also done, they formed inside the triangle at the vertices. Now this thing base. Okay, so what is the base of the triangle? So let me draw one triangle there. Suppose this one is the triangle and its name is ABC. So it's written there, any side of the triangle can be taken as the base. Okay, so we can say AB is the base or AC is the base, BC is the base. But when the triangle is made like that, then generally we take the bottom one as the base. So in this we can say BC is the base here. Okay, but in the case, suppose I have another triangle and I drawn like that this time A, B, C. Now for that case, we can say our base is equal to AB. Okay, so there is no such criteria for base, but we generally take the bottom one. Okay, now the next one, altitude. So a perpendicular drawn from a vertex to the opposite side. Okay, so we all know actually what the vertex is. So now we will draw some perpendicular so it will be more clear to you. Now in this triangle ABC, A is one of the vertex. Okay, so if from A, if we draw perpendicular to the opposite side, which is B, there. Perpendicular means the angle where they intersect is 90 degrees. Okay, so this one is the altitude, and suppose this point is D. So we can say AD is height or altitude. Okay, and you can verify from the definition itself, a perpendicular drawn from a vertex, which is A there, to the opposite side, which is BC. Okay, so that's our the definition of height. Now the next one, which is median. So it's a line segment joining a vertex to the midpoint of the opposite side. Okay, now look clearly. There is some difference in them. And now we can change the name. It's suppose P, Q, and it's R. Suppose from the P we can draw the bisector there, which means suppose it intersect at S, then QS and RS are equal, which means QS is equal to RS. Okay, that's the median. A line segment joining a vertex to the midpoint of the opposite side. So we can say S is the midpoint, which means QS is equal to SR, or we can say PS, this one is our median. Okay, PS is equal to median. Now the centroid, the point where all three medians of a triangle meet. Okay, so this is one of the median which we have drawn from the vertex P. Suppose we also draw a median from vertex Q and it looks like that. And from R we also draw some median there. Okay, and they intersect at that point there, the red color one. Okay, this point. So we can say, suppose this point is O. So we can say the point O is our central. Okay, now the orthocenter, the next one, it's written there the point where all three altitudes meet. Okay, suppose in any triangle, we have drawn some perpendicular there. Now this time it's not the midpoint. Okay, there is no such conditions that these two sides are equal. Only condition is that this angle will be 90 degree. Okay, that angle, this should be 90 degree. And suppose it's A, B, C, and one perpendicular there. Now the next one is there. Okay, all these angles are 90 degree. And suppose this point is O where all they meet, which is there. So we can say in that case our O is equal to orthocenter. Now the next one, circumcenter, it's their perpendicular bisectors of the side meet. Okay, in this we have one more conditions like perpendicular bisector. Okay, suppose this one is the triangle and we have drawn, suppose this is perpendicular and all the sides are equal. Okay, so in that case we can say this point is circumcenter. Okay, which is this one. Generally we don't use such words in our chapter, but these are very necessary if we do some proof as well. Okay, now the last one, in center, the point where the angle bisectors of the triangle meet. Okay, so this one is, I am explaining. Suppose this one is A, B and C. Now this one is angle A. Suppose I have drawn a line with opposite side such that it breaks this into two equal parts, which means this angle, this one is equal to this angle. Okay, now if we draw same lines like that, so the center there, this one, is known as in center. Okay, so that's all about the basic properties and which are the terms associated with the triangle. Now we can say the type of triangles we are able to do that. Suppose we have to cover triangle, then there are some criteria in which we can classify them, like based on sides. I am making flowchart for you, and the another criteria is we can uh, partialate between them using based on angles. Okay, and based on side, there are three criteria in which we can classify our triangles. First one is scalene, isosceles, and equilateral. Now for a scalene triangle, it's written that all three sides are of different length. Okay, suppose I have made a triangle. I'm drawing just in front of there. Suppose it's A, B, and C. It's given that AB is not is equal to BC and not is equal to AC, which means AB does not is equal to AC, does not is equal to BC, which means all three sides are equal. No, all three sides are not equal. So we can say this triangle is scalene triangle. The other property of that is that all three angles are also different. Okay, which means we can write angle A does not is equal to angle B does not is equal to angle C. Now the next one is the isosceles triangle. Isosceles triangle, in we have two sides are equal in length. Okay, not the three, only two sides. So if we draw the isosceles triangle there, then any two sides are equal but third one is different. Okay, which means A, B, C. We have AB is equal to AC, but both of them should not be equal to BC. Okay, and it's also written that angle opposite the equal side are also equal. So AB, this one is equal to AC. Now if we look to AB, then its opposite angle is angle C, and for AC its opposite angle is angle B. So we can directly say angle B is equal to angle C, but it's not is equal to angle A. Okay, that's the point. Now the last classification based on the side is that equilateral triangle. So equilateral triangle is the triangle in which all three sides are equal. So we can draw. Suppose it's our triangle and this side is P, it's Q, it's R, then all three are equal and all three angles are of 60 degree, which means this one is 60 degree, this is also 60 degree, this is also 60 degree. So in equilateral triangle, we can say PQ is equal to QR is equal to RP. Okay, that's the condition. Now these are the classification based on the sides. Now we have some more classification of angle based on angles. So first of all, acute angle triangle. So it's the triangle where all three angles are less than 90 degree. Suppose I have drawn this triangle, it's PQR, and we know that angle P, angle Q, angle R, all are less than 90 degree. So we can say triangle PQR is acute angle triangle. Okay, now the right angle triangle. So it's written there, one angle is exactly is equal to 90. So if we draw any triangle such that any one angle is equal to 90, then we can directly say it's the right angle triangle. Suppose it's ABC, then we can say directly triangle ABC is right angle triangle. And this thing we already know, we have done in previous classes, that side opposite to the right angle is called hypotenuse. So it's right angle. Now AC is the hypotenuse. Okay, this one is hypotenuse. Now the last one, obtuse angle triangle. The triangle in which we have one side greater than 90 degree, like that. This one is greater than 90 degrees. So we say, suppose it's PQR and this angle, suppose angle Q is greater than 90 degrees. So we say triangle PQR is obtuse angle triangle. Okay, obtuse angle triangle. Now it's all for the triangles and its type. Now we are able to come to our main topic, which is the congruence. Okay, so before doing that, if I tell you like we have one triangle there, okay, not triangle, just we will cover for the basic things. Okay, there is some figure and there is one also same figure. Okay, so if I place this figure in front of this, so it will cover, we can, now someone will say there is only one figure, it overlap completely, it will overlap completely. So we can say in such cases, when two geometrical figures are just like same or they are equal, then we use the word congruence. Okay. In mathematics, we use equality, but in geometry, we use congruence. So now we can read, the word congruent means equal in all respects, which is same size and same shape. Now in geometry, two figures are congruent if they can be placed exactly on top of each other, which we have done in this thing. Okay, these both are congruent, this one and this one. So congruence is like perfect matching, it's written there. Now there are some examples given which we can observe in our daily life. You can pick two 1 rupee coin and you will find that they are very similar and they are congruent. And if you want like example right now, the notebook in which you are making the notes of our class, you can check that two pages of same notebook are congruent rectangles. Okay, they are very similar. Now if we come to our topic, like congruence of triangle, then it's written that two triangles are congruent if they have exactly same size and shape, which means suppose one triangle is that. Okay, and the another one is this triangle. this is of red color. Okay, so if we say they are congruent, then their shape and size are both same, and we can see from the figure itself that it is so, which means their corresponding sides are equal in length and corresponding angles are equal in measure. Suppose this triangle is triangle PQR and this one is ABC. So we can say triangle PQR is congruent to triangle ABC, and for congruency we have the symbol this one. Like first of all we have to make equal to sign and some design like that. Okay, it is a tilt like. So it means triangle PQR is congruent to triangle ABC. So it's all for this video, and we have done many topics in this video, which includes the basic things about the triangle and its like associated terminologies and their basis, and actually what the congruence means, and later on we discussed about the triangle. Okay, so before the next video, I hope you will revise all these things, so keep practicing, and if you got any doubt, then you can ask me through my Urban Pro profile. Okay, thanks.